So, for solving this problem, uh, well, we know that there's a boat that starts like here and it goes north for 20 seconds at a constant acceleration, and at some point, well, 20 seconds, and at some point it starts going west, and I don't know, it starts going from here with the same speed it had. It started going to this side for 10 seconds. Okay. Here we know that it's 3 meters over second squared, the acceleration. What do we do now? So, uh, this time we should not start with part A, but with part C. That is the easiest part to do. Okay? So, we know that here, in the green part, let me rewrite it with green. Uh, in that green part, we know that there were two moments. Uh, the one that it went like to the north and the one that went due west. So we will start with the part that went to the north. That is, the position in the y-axis is going to be equal to the initial position plus the initial velocity uh, in y plus times time plus a half of the acceleration times t squared. Okay, initial position we're going to assume it's 0. Initial velocity it says it starts from rest. That's going to be 0. And the acceleration, we know it's a half of 3 g squared. Okay? We know this because it just moved here in the y-axis. And that, if we just expand this thing, it's going to be a half of 3 times 20 squared. And this is going to be 600 meters. Okay? So that is for the first part in green. What happens with the part in blue? For the part in blue, we can start like doing exactly the same analysis, but this time there was no acceleration. Okay, so we know it started here and started right there. Okay, so it started in 0. We can consider that this is the origin. 0, well, let me write the formula like up here, like 0 plus v0t. Okay, and x. So initial position is 0, initial velocity, we need to compute it. We don't know it by now, but we can know it. How do we know the velocity? We know that velocity is equal to the initial velocity times acceleration times time. Okay, so this is initial velocity 0, acceleration is 3, and time is 20, excuse me. So this is 60 meters over second. Okay, so now we know that so that would be 60 times t, that was 10 seconds. So this is negative actually because it's going to the left side. Don't forget that. So this is minus 600 meters. And actually it makes sense because it's going left. You can see it like here. It's going left. Okay, so we know the final position now. The final position is vector 2, we're going to call it. It's minus 600 I plus 600 J. Initial position, or position 1, is 0 I plus 0 J. Okay? So, we have partly answered C. Not at all. Okay? Not completely. We have to answer A first. For making it like far much more with sense. Let me turn to red. Red. There we go. So, here we are. The average velocity, we know it's R2 minus r1 as a vector. This all over final time minus initial time. That's gonna be minus 600 I plus 600 J. That's the R2 minus 0I plus 0J. There we go, all over 30. Okay, so from there we just know that that be minus 600 I plus 600 J over 30. The 0 goes out, and they are just left with minus 20 I plus 20J. Okay, and that is the average velocity. That's part A. Now, part B. Let me change color to, I don't know, black. Let me write here A. Part B. We know that the velocity from here, computed it there, it's just going, the final velocity here, that's gonna be minus 60I plus 0J. If you're wondering where this came from here. Okay? It's going west, therefore this is negative. So this thing is gonna be average acceleration. It's gonna be final velocity vector minus initial velocity over time, final time minus initial time. This is minus 60I plus 0J over 30. Well, minus 0I plus 0J. This is nothing more than minus 2 minus 2I plus, oh, let me erase that. Sorry, this thing's failing, I don't know why. There. Plus 0J. This is the average acceleration. Okay, finally, I know this video has been very long, but this is a very complicated problem. Part C, we just need to get the magnitude of the subtraction. Okay, that would be the magnitude of R. It's gonna be the square root of 600 squared plus the magnitude of minus 600 squared. And that's gonna be equal to 848 meters. And there we go. Yeah, this problem was very, very complicated.